everybody to the February Brown Bag webinar. My name is Tess Konovich, and I'm the Scientific Marketing Manager here at EarthShift Global. And I'm so pleased today to welcome two of my colleagues and coworkers, Mariana and Noel. Mariana is a Senior Sustainability Analyst at EarthShift Global with extensive experience in life cycle assessment and sustainability analysis across agriculture, textiles, industrial processes, and energy systems. Prior to joining EarthShift Global, she led a sustainability consulting practice focused on agriculture, forestry, livestock, and fisheries, supporting consulting firms, government agencies, and nonprofits. At EarthShift Global, Mariana works on LCAs and policy-driven analyses, including projects supporting the 45Q tax credit. Her work spans material flow accounting, handprint assessments, SROI, and LCA for climate and energy programs, with a strong emphasis on translating technical analyses into defensible, decision-ready insights. And Mariana holds a bachelor's degree in environmental engineering from the National Polytechnic Institute in Mexico and an Erasmus Mundus master's in industrial ecology with specialization in LCA at Leiden University's Institute of Environmental Sciences. We also have Noel Stoddard here today, a junior sustainability analyst. Based in Brunswick, Maine, Noel brings a multidisciplinary background in life cycle assessment, physics, and education to sustainability consulting. He holds a bachelor's degree from Bard College and a master's degree in physics with a focus on energy and climate from Radboud University. And since joining EarthShift Global in 2024, Noel has contributed to LCEs across electronics, carbon capture, textiles, and end-of-life modeling, including work supporting 45Q related projects. His expertise includes the quantitative assessment of material and energy systems, with particular experience in electronics reuse, circularity, and semiconductor and chip reuse research. Prior to graduate study, Noel taught math and sciences in Midcoast, Maine. His background is in computational modeling and condensed matter physics, and it continues to inform his analytical approach to sustainability and environmental decision making. Every time I speak with my colleagues here, I learn something new, and I don't expect any different today. So with that, Noel, if you'd like to take it away, we are ready for you.
Thank you so much, Tess. Welcome. We're actually going to pass over to Mariana to get us started on today's webinar.
Thank you. Thank you, Tess, for presenting us. Welcome, everyone. We are so happy you are joining us for this Brown Bag webinar. And the topic today is the critical role of life cycle assessment in securing the 45Q tax credit. Let's go to the next one. We have this agenda. We're gonna give like a basic introduction to the 45Q, and we wanna present to you a little bit about what are the requirements for modeling and reporting, the guidelines that we have to follow. We'll delve into the product systems that we need to compare for this program, what we mean by system expansion and the importance of the market system. What is the equation we have to consider in order to know how much credit one can get, and a little bit on review requirements and our services, and then Q&A, of course. So for introduction, let's go to the next one. As you may already know, be aware of, there are these general systems of environmental management that one can apply. So there's command and control, when authorities set a limit to pollution, and so producers need to comply to those or will be reprimanded. There are also voluntary actions or voluntary agreements that industries can participate in. These can also be designed by authorities, could be, but they're voluntary. They choose to do more besides what is required by law. And then there are economic incentives, and these are interesting because the framework is set by the authority to say, well, I need to do more. I need that there's more about this specific management of carbon. In this case, more of these technologies in place. And for that, I say if you out there in the market implement this, then you get a benefit. And in this case, the 45Q tax credit is a very good example in the US for an economic incentive for companies to do more of certain technologies for managing carbon. Let's go to the next one. So the 45Q program is part of the section of the 45Q of the US tax regulation, and it provides a performance-based tax credit for certain carbon management technologies. Those who can claim the credit are those who are doing secure storage in appropriate geologic formations of the carbon captured, or they are using the captured carbon to produce low embodied carbon products. And that can be, you can think of any industry, right? So which carbon oxides qualified? Well, that carbon that is fixated through photosynthesis or chemosynthesis, or and that is securely stored through chemical conversion in a material or a product, a chemical compound, or that is used for any purpose that fixated carbon, taken carbon, capture carbon, and use it for in a product for a use where there's a commercial market, right? Except they use for tertiary injection in enhanced oil or natural gas recovery projects. So the carbon dioxide can come from industrial facilities, from power plants, or from the air. We can go to the next one. And how do we determine if a 45Q credit can be generated if you are capturing carbon? Well, that's the critical role of the LCA because this analysis is at the core. You need to show with the LCA that the process that you are proposing stores more carbon than it uses, and there are savings in emissions as compared to the incumbent technology, the one that is the more common in the market that you are comparing to. So how do you do it? Noel will explain us.
Perfect. So in order to get this credit, a full LCA has to be conducted. And to do that, we have to start with everyone's favorite part of the process, which is guidance documents. At its core, there's really four guidance documents that you need to be familiar with before starting this long process. Two of them will be very familiar to any LCA practitioners. Those are ISO 14040 and ISO 14044. And that really is the backbone of this LCA process. It's following all those same guidance. But in addition to that, there are regulatory requirements for doing an LCA specifically for 45Q. And those come from these two documents over here. This is the carbon dioxide utilization LCA guidance from the National Energy Technology Laboratory, or NETL, as we'll call them. And this is really the parent document that has a lot of information on your choice of functional unit and the system boundaries of your product and the way that you'll do data collection and the way that you'll do sensitivity analysis and all that sort of thing. On top of that, there's a specific addendum for 45Q. It's a little bit more condensed and it goes over some of the requirements specific to this process. Unfortunately, you'll still have to be familiar with both of these, as sometimes the addendum will reference the original one and sometimes it'll overwrite it. So this is really the first step on the journey, is to be familiar with how these projects are put together. These documents, as well as most of the other tools we'll talk about, are all available for free on NETL's website. They have a toolkit that you can download that will provide everything you need. One of those tools is a database. So wherever possible, you should use the database provided by NETL. And it's specifically for doing these LCAs for 45Q. And you can see over on the right the sort of data sets that they have available. This is not an exhaustive database of everything that exists. So if you find yourself in a position where you need to model processes that are outside of this database, you can use other verified databases such as EcoInvent or any other ones that are publicly available. The assumption, though, is that wherever possible, you'll use the NetL database, especially for things like transportation or any energy production or anything like that. You'll also notice that this database is in OpenLCA as a platform. That is the default for NetL and for the Department of Energy in general. It is not required, though. If you would like, you can use another LCA software like SEMA Pro or LCA for Experts. However, you'll have to make sure that you can port over all the information from this database as well as their impact methodologies into your preferred software. The third option is to use neither of these and to use a pre-made Excel model that is available from NetL as well. In our experience, that model works for more simplified processes, but is less flexible and powerful than full LCS software. So that's our preference. Another thing you'll find in this toolkit is the template for the report you have to write. If you've written ISO 14040 reports before, you will be familiar with a lot of the things that are required. You need a goal and scope to outline your inventory, your impact assessment, and interpretation. However, there's a lot added into this report template that's not in a typical ISO report. Just a little bit more specificity when it comes to things like data representativeness, when it comes to the type of sensitivity analysis run, and things like carbon, energy, and mass balance. So another thing before really starting your model is you want to look through this and see what will be required at the end of the process. And once that model is complete, once you've written your report, you need to determine how much of the carbon that you capture will actually qualify for this tax credit. And that's where this equation comes in. It's sort of the final deliverable from this process where you put the total impact of your system and you compare it to a representative product system called the comparison product system. And you scale that impact by how much carbon is captured. At the end of all of that, you'll get some sort of number, and that number will essentially tell you the percentage of your captured carbon that qualifies for 45Q. So after you put all this in, if you get 1 or more, that means that 100% of the carbon you capture will qualify for the monetary value of the tax credit. If you get a number between 0 and 1, that means you'll get some percentage. Might be 75, might be 35. And if you get a value less than 1, it means that your system, the addition of the carbon capture makes your system much more impactful than whatever carbon is saved, and you don't qualify for the tax credit. As you might imagine, the maximum value for this output is 1, as you can't qualify for more than 100% of your captured carbon. So with all that, I'll pass it back to Mariana to talk about how you define the product systems.
Yeah, as you saw in the equation, there is the proposed product system and the comparison product system. So we're going to show you an example of what those could look like. Of course, every project is different, but this one is for a simplified. Let's think of a very simple product, dry ice, which is just CO2. So what are the project boundaries? Where does the LCA start and end? It has to be a cradle to grave comparison. But as with any LCA, processes which are the same between these two systems can be omitted. Especially this will happen at the end. So here you see in the proposed product system that we account, well, this is biogenic sourced CO2 for making dry ice. So the process entails some crop production and all the inputs that are required for that, transportation, further processing, and then obtaining the biogenic CO2 from fermentation, and you have other co-products. And then modeling also all the other stages, upstream, downstream, for cleaning the CO2 and manufacturing the dry ice. And then at the use phase, you again will have the emissions of the CO2, in this case, biogenic CO2. And that would be the proposed product system. This would be the one that is claiming the credit. And it's gonna be compared to the comparison product system that in this case, for the example, we are assuming is going to come from completely fossil CO2 that was captured from an ammonia production process using natural gas and other inputs. So these would be the two systems that are gonna be compared. And one thing to notice here, if you see in that light green, we have our main carbon product, capture carbon that we are assessing. And in gray, we have the co-products that are, well, also part of the system in reality, but the modeling approach we are taking here is we're allocating the impact of the processes into these two co-products in, but as Noel will explain next, more recently, the guideline or the 45Q addendum specifically says it's appropriate, the most appropriate way of modeling is doing system expansion and not so much allocation when it can be avoided. So take it away now.
Exactly. So with these products, there's often co-products and waste products involved in any of these systems. In some cases, it could be that, like in the last example, the CO2 is a byproduct of some other process, or maybe like in the example I'm about to show, there you're capturing CO2 directly from the atmosphere and combining it with some other waste product to create what's called a carbon embodied product. So the CO2 lives within that output. When this happens, we have to figure out how to account for all of the impacts associated with both processes. So if the biogenic CO2 or if the fossil CO2 is coming from an ammonia process, well, those two outputs have to share some sort of burden. Typically, this could be done with allocation. So I'll show the example here where we have this. Our proposed product system is really we just take this feed material and we combine it with CO2 from the atmosphere and we create a product from that. But this feedstock comes from somewhere else. And if we don't do any kind of allocation, this will have to be treated as virgin material, and that will increase the burden of the system as a whole. And this is relevant because at the end of all this, we're still trying to get back to that equation. And the performance of our system in terms of environmental burden will directly affect how much of the 45Q credits can be applied for. You can do allocation between these two products, so this product X and this embodied carbon product. However, that's still going to end up adding extra burden to your system, especially if what you're using is a waste product. So this is what it looked like if we did system expansion. So now our functional unit is not just looking at this embodied carbon product, but also whatever this co-product X is. This may be very familiar to LCA practitioners, but we emphasize it here because it is so explicitly discussed in the guidance documents. They really want you to do system expansion. And we think that it's actually worth it in the long run for any applicants because they're likely to have a better result when comparing their systems. Even though system expansion typically does require more work in data collection, more data shared, and more work on the modeling side as you're modeling two systems instead of one. So this is really our pitch to if you're in this, if you're wondering if it's worth doing system expansion, it really is. And that will allow you to compare your expanded system to potentially two separate comparison product systems. Deciding what those are can be really difficult, though, and for that, I'm going to pass it back to Mariana.
Yeah, because the comparison product system has to be modeled considering kind of the market for the US. How are those products that are functionally equivalent to your proposed products being produced in the market? Let's go to the next one. So you have to do a robust documentation because modeling the comparison product system has to be done according to the state of the market. So if in the market, if CO2 is sourced from one of the top sectors that are conducting carbon capture already, the existence of carbon capture has to be reflected in the comparison product system. So let's think about again of that simple example of the dry ice. Um, Remember that in the comparison product system, we showed you we were considering 100% fossil sourced produced dry ice from ammonia production, so 100% fossil. If we assume that as our comparison product system, in comparison to the PPS, and now I ask you to look at the graph, this is what we get. In blue, you see the downstream emissions, all that it took to produce, capture that CO2. For the comparison product system, that gray, the emissions shown in gray are the emissions at the end of life, and for the 100% fossil, well, those are all fossil emissions, right? In the biogenic case, because of how we build the model, we can consider that the lighter gray emissions are biogenic, and so we can consider them as zero, right? So you get the difference in the two systems are quite large, right? So you can expect a good result for the amount of credits that you may get. But as it turns out, in the carbon market mix, when we go and do the research about the sector, we see that in reality, for the dry ice market, it's not only 100% fossil carbon that is being bought for the users of the of the CO2 for making dry ice. It's really a mix of fossil carbon and biogenic carbon. So we have to know how much is of each one and do the correct market mix. And for that, the guideline proposes a step-by-step of rules how you should account for this or consider this, right? But you see the difference now when we consider the real comparison product system and we have a mix at the end of life of biogenic and fossil fuel, well, then the difference between the PPS and the CPS is smaller. So you will get a smaller amount of credit because of it. We can go to the next one. So for that, the equation again. Let's go to the next one. If you remember the life cycle 45Q displacement factor is the total amount of emissions from your PPS minus the total from the comparison product system over the total amount that you are wanting to get credit for your functional unit, the total amount of carbon you have in your product. So let's go to the next one. Here you see a simple substitution of a made-up example, considering that our functional unit is 1,000 tons of CO2 and our proposed product system emits 793 tons of CO2, and the comparison product system, in the case where we consider a market with biogenic and fossil fuel, is emitting 1,400 tons in comparison to the other comparison product system, let's say in a sensitivity analysis, when we consider 100% fossil carbon, it's 1,800 tons. And so below you see the result for the displacement factor. For the biogenic and fossil, you get 63, so 63% of the total potential credits. In the other case, you would get 100 because, as Noah mentioned, you can only get 100, even if you get 1.03 or 3 or 100 as displacement factor. So one more thing I want to say is this is kind of where we start having more interesting conversations with our clients when we get to how much, what percentage of the credit they can get, right? Because in these projects, in many cases, we are not so much working with the sustainability department of the industry, but more with the accountants or a mix, right? But of course, people want to get hundreds, so it's good to do a screening and scoping of the results before making plans, maybe to review our expectations before assuring that something may be true. It's good to check. Hmm?
And one thing I'll just add there that I didn't mention earlier when we were talking about this equation is the way that the value of the tax credit is calculated is there's a dollar value per ton of CO2 captured. And that value will change whether it's captured from the air or from an industrial process and a few other factors. But essentially, if this this all gets us this number, and then separately you'll report, okay, we captured 10,000 tons of CO2, each one of those at 100% would be multiplied by that number. But in some cases, it'll be a percentage. So those numbers do change from time to time with different legislation, but that's how the value after this is then calculated.
Mhm.
But let's say that you've already calculated all this and you have your report and everything. What do you actually need to pull together for submission? So it all comes down to really these four pieces, as we mentioned before, the report, following ISO, following the addendum, and as I said, I highly recommend to look at the template and use that as a guide when writing these. But in addition to the report, you also need to provide the LCA model itself. So usually that's in the form of a database, or if you're using the Excel model, you send that whole Excel model to the submission as well. And then any documentation. So especially if you are changing, if you're taking the Netel database and changing to another software platform, you'll have to document that as well. And then you'll also need a critical review statement. And while there's the normal critical review requirements, as before, there's a few extra on top of that. The critical reviewer needs to have a professional license. They need to be familiar with the guidance documents, and they also have to review the model itself and the data of that model. So that could be through sending them the model and having them review it as part of their review process, or it could also be having a meeting where the practitioner walks the reviewer through the different pieces of the model so they can check its veracity. And then with all that, you also have one more form, which is the actual IRS form, the tax form, and all of this is going to go to the IRS in the end, as it is the Department of Energy who has set a lot of these tools, but it is the IRS who makes the final designation for the tax credit. I know that's a lot of stuff, and hopefully that's somewhere where we can help you out. And so I'll pass it one more time back to Mariana.
Yeah, so we want to partner with you if you're applying with the credit. If you would consider us, we can go to the next one. We can do anything, support you every step of the way. We can either perform the LCA and write the report and help coordinate with an independent reviewer, or we can also be reviewers. We cannot do both, right? Because we cannot do both things. It has to be an independent critical review. Yeah. We can also help in filling out the form. We have done that before because there are parts that need some, well, that can be aid with the knowledge of how the numbers. So we can work together with your accounting department. And yeah, that's it. The final paperwork in the submission is on the applicant. That we don't do, but we do accompany our clients all the way until they get a response from the authorities. So yeah, we're ready this.
Excellent. Thank you so much, Nola and Mariana. I learned a lot. I'm sure our audience did too. And we already have some questions. So again, you can place your questions in that Q&A tab at the bottom of your screen. I'm going to start reading them aloud, but feel free to put more in now and we will get started. So question number one, hi again, Jason. It's nice to hear from you. Is there a required process for third-party verification or 45Q LCAs? Are there required qualifications for verifiers?
Well, I can take this first one since we touched on it a little bit earlier. But yeah, they're the requirements, they're the ISO specific requirements, which are listed on that slide. And a professional title, in the past, we've used reviewers who are or professional engineers, and that qualifies with the IRS. Apart from that, it's the normal LCA critical reviewer requirements. Yeah.
Thanks, Noel. Okay, oh, we got a few more in. Exciting. Okay, our next question is what kind of professional license is permissible for critical reviewer?
So far, we have worked with licensed engineers, and for us who do the LCA, a certified LCA practitioner.
Thanks, Mariana. The next question is how many 45Q LCAs has our team submitted which have been accepted and received the 45Q production tax credit for a given tax year? Do either of you have that answer?
We have done a handful, that's what we can say. And we cannot say how many have gotten the credit. We can say that we walk with our clients through all the way, and it doesn't matter how long it takes. Whenever there are questions from the authorities reviewing the study, we are there to support them. We cannot assure that having critically reviewed the study, there won't be questions, or that you will get the credit 100%, because that's out of our hands, right?
I think we can share that when we have gone through the critical review process, we've been able to produce reports that earn that critical review stamp at the end. Beyond that, there's NDA restrictions, but uh, we've produced successful reports for our clients.
And maybe we can also add that the Department of Energy and the NETEL are updating the guideline in the addendum. So far, there has been one big update, and so we have become familiar now with with the guidelines, with what is to be done. We feel confident about that, but each project is different. So it's a new project. Each one it's about understanding the market, a different technology. So yeah, each
Thank
one
you.
is new.
And seeing how much of a critical role LCA plays, I'm sure the answer to that question is it depends on a lot
Mhm.
of factors. So thank you for that. The next question is, do you know why GREE was not used as the model of choice?
So, if you have an answer, Mariana.
Well, we can do it together. I can start if you want.
Yeah.
My guess is, as I said, each project can be really different, um, and innovative, right? I think this program was thought for fostering innovations in carbon management. That's the whole idea. What you have in grid is usually something that has become more standardized, and you have pathways that are placed there because it's more known. The projects that we deal with in 45Q could be anything, could be some known pathway, but could be very innovative. So I think the grids tool, it could be difficult, more difficult to handle it in the grids tool. What do you think, Noel?
Absolutely. And something that I didn't mention when discussing the 45Q database is that along with that comes a 45Q impact assessment methodology. And it's interesting because it is somewhere between two different versions of the IPCC AR5 and AR6 climate change impacts. However, because one of the reasons why the specifics are so kind of ironclad in this whole process is that they're set out in an act of Congress. So in order to change any of those things, it would have to go through that in order to be updated. There's a webinar that Netel did a while ago, and they discussed and they said, this is the impact methodology that we have, and it requires a lot to change it. So maybe it also was a simplifying thing just to go down to one impact category in such a way that they could define everything in that database. But it's a good question.
Thank you both. That was thorough. Okay, the next question is the procedure presented the same for both CCS and CCU?
Yes. I think it is the same. The difference is in the value of the credit. So if you look, there's a little table somewhere that says the type of capture, whether it's direct air capture or industrial, and then also whether it's being used displacing a product or whether it's storage.
Excellent. If I have a new process that sequesters carbon in a building product, can I pre-apply for a credit before starting the business so I know what we can expect?
We can help you scope, screen what the credit could be, but I don't think you can apply because the credit is only for projects, technologies that have been already operational at least for one tax year. So we do have get a lot of potential business development calls for projects that are, yeah, testing their innovation and are at a level that they are operational, but they are not yet operational. But they cannot apply for the credit, yes. So we can help scope what the results could be, but eventually you would have to wait to be operational to then apply.
Okay, we have two more questions. So this one is, should NETL datasets be prioritized for the PPS and CCP? For example, datasets to inform emission factors and US average production methods for a given product.
Yes, whatever is available in the Nettle database, you should use. We use, but we seldom work only with the Nettle database because projects are each technology is quite specific, and we do account for all of the stages and all of the inputs as much as possible because the guideline specifies that you can do 1% cutoff. So it has to be quite complete. And we find that the database available has a lot of very specific processes that if there, use them. But you will need more. In our experience, we have needed much more.
Yeah, it has a lot of strength in a few very specific areas. Is a lot of regional specificity in the different areas of the U.S. for industrial processes and energy production. But if you're trying to characterize something that isn't within that, definitely need to pull in some other data.
Thank you. Okay, this last question is mine. So, can you talk more about the difference, if there is one, on how biogenic carbon and carbon oxides are handled in this?
Uh, yeah, it all depends on the on how you model it. Depending on the data set that you are using, you might be um, taking some credit for biogenic carbon in the beginning. And if you do that, then you cannot claim the biogenic emission as zero at the end of life, right? So you have to be careful on that. That's the kind of care you have to take regarding biogenic carbon. Hmm, do you
One
think that?
other, just the carbon oxides part at the end made me think that throughout the documentation, they always talk about qualified carbon oxides. And almost all the time, or in our experience, most of the time, it's carbon dioxide, but it could also be carbon monoxide. Other carbon oxides can be captured and qualify. Um, just if you're reading that, that's what that means.
And in fact, in the latest update of the addendum, they mentioned that by carbon oxides, you can they're using it as a synonym of carbon dioxide.
Hmm.
Okay, we had one more come in. So, can you comment on how this process might be applied to Canada?
In what sense, developing a program of incentives for implementing carbon capture and carbon usage technologies in Canada? I think yes. I mean, there has to be an evaluation of the policy to see how much it is improving the situation, and based on the evaluation of what was a success, what are the learnings, then Canada can could take on that and build an even better program. I don't know if the question is related to that, but it's an interesting question. Feel free to reach out
Yeah,
to speak more about it.
I definitely agree. And I think it's a very particular incentive that they're setting up is to, there was a question earlier about what can we apply if we haven't gotten to production yet? But I think a lot of the impulse behind this is to incentivize people to take these to really start one of these productions that might be riskier. But if you know that there's a tax incentive, then maybe you're developing more sophisticated carbon capture or more ways displacing fossil carbon. Uh, and that's exciting. So I think that's one hopefully success of this is incentivizing people within the US to do that. And if any other country wants to do that as well, that seems like you're fostering innovation and in your own country, and then also hopefully reducing your climate impact.
Perfect. And as Lisa just commented in the Q&A, we can help with the LCA for the Canadian Clean Fuel Standard at EarthShift Global. In our recent edition of The Shift, Sarah Donovan, one of our sustainability analysts, actually wrote an article on that. So feel free to check that out. We have that on our website as well. And Noel, would you slide to the next slide in the slide deck? Like Mariana said, if you have any questions, here's their contact information. Thank you all for being so engaged today. I just saw the questions. I want to make sure I got to them. Yeah, perfect. We got to all 10 questions. Great job, team. And thank you again for such an engaging presentation and for our audience for being so engaged. And stay tuned. We'll be sending out next month's webinar. Sneak peek, I'll be presenting. I'm really excited on data visualization and life cycle assessment. We'll also be announcing some of our training soon, so stay tuned. If you haven't subscribed to The Shift, go onto our website. It's our monthly newsletter. We send out all of the exciting things that EarthShift is doing. And thank you again for joining, and I hope to see you all next month.